Have you ever looked at a really big number, like the distance to the sun, and your brain just kind of goes fuzzy? Well, today, we're going to unlock a super simple trick that makes those giant, scary numbers surprisingly easy to deal with. Let's get right into it.
It really all boils down to this one question. How can this tiny little number, the one you see written up high, be the secret key to understanding a massive number with a ton of zeros? It sounds a little crazy, right? But that's the puzzle we're going to solve. And the answer is, well, it's pretty cool. All right, so how do we crack this code? It all starts with something called powers of 10. Now, I know that sounds like it's straight out of a math textbook, but trust me, it's not scary at all. It's basically just a secret language for talking about zeros.
Okay, so check this out and look for the pattern. 10 to the power of 1 is just 10, 1 0. 10 to the power of 2 is 100, 2 zeros. Are you seeing it? That small number up top, the power, it's literally just telling you how many zeros to tack on after the number 1. So, 10 to the power of 4, easy. It's a 1 followed by 4 zeros. 10,000. Simple.
Yeah, so that little number has a fancy name. You can call it an index or a power, but honestly, just think of it as a command. It's like a little boss telling you, hey, put this many zeros right here. It is, without a doubt, the ultimate shortcut for dealing with huge numbers. Now for the really fun part. What actually happens when we use these powers of 10 to multiply things? This is where the magic trick comes in, and it's all about one simple predictable move. And here it is, the golden rule. When you multiply by a power of 10, you don't actually change the numbers you're working with. They just slide. They all shift their position over to the left, getting bigger with every spot they move.
Let's see this happen in real time. Say we have the number 23, and we're going to multiply it by 10 to the power of 4. So what's our command? That little 4 tells us to move the digits 4 places to the left. So watch. The 2 jumps over 1, 2, 3, 4 spots. The 3 follows right behind it. And what about those empty spaces? We just fill them with placeholder zeros.
And just like that, 23 times 10,000 is 230,000. Did you see that? No complicated multiplication, no need for a calculator, just a simple slide to the left. It's clean, it's fast, and it is seriously powerful.
Okay, so if multiplying is all about shifting to the left, what do you think division is? You've probably already guessed it, right? It's the exact same logic, just going in the opposite direction.
Yep, the rule for division is just as easy. When you divide, the digits move to the right. Every spot they shift makes the number smaller, sometimes even making them hop right over the decimal point.
Let's give it a try. We'll take 45,000 and divide it by 10 to the power of 5. That little 5 is our instruction. Move everything 5 places to the right. So here they go. The 4 and the 5 start sliding over 1, 2, 3, 4, 5 spots. They jump clean over the decimal point, and the 4 lands in the tens place with the 5 settling in right next to it.
And the result? 0.45. We turned a big number into a small decimal just by sliding its digits around. Again, no need for that messy long division. It's all about knowing which way to move.
Okay, I know what you might be thinking. This is a neat little trick, but is it actually, useful? Oh, absolutely. Let's take our new skill and apply it to a real-world problem that sounds super complicated at first glance.
So here's our challenge. A kilometer is huge, and a millimeter is tiny. Trying to figure out how many of one are in the other, well, in your head, that seems almost impossible. But with powers of 10, it's going to be a piece of cake. So the first thing we need is the secret code, the conversion factor. And to get from kilometers all the way down to millimeters, the magic number is 10 to the power of 6. That little 6, that's the only key we need to solve this whole thing.
So what exactly is 10 to the power of 6? Well, it's a 1 with 6 zeros. It's 1 million. Now that number sounds enormous, but we know the secret, don't we? It's not really about multiplying by a million. It's just about shifting some digits 6 times.
And here's the payoff. We take our 9 kilometers and we follow the command from that power of 6. We just slide the number 9 6 places to the left and fill in all the empty spots with zeros. And the answer is 9 million millimeters. Just like that.
So, let's just recap the 3 big takeaways. Number 1, the little index number is just a command telling you how many zeros you're dealing with. Number 2, when you multiply, you shift everything to the left. And number 3, when you divide, you shift everything to the right. That's it. That's the whole system.
So now you have this new tool in your mental toolkit. Think about it. The distance to the moon, the number of stars in the galaxy, the national debt, all those huge, intimidating numbers aren't quite so scary anymore, are they? They're just digits waiting for you to shift them. So my question for you is, what big number out there suddenly seems a lot smaller now?